Dear students, in last class we studied hydrology and then mass curve. In today's class, we will take up the flow duration curve, importance of flow duration curve, and then the classification of hydroelectric power plants. To understand what is flow duration curve, let us consider here a water storage from where the water flows out at a rate of Q meter cube per second. And for this tank, let us say we are having flow rates available for 10 days as follows. In this table, you can see the flow rates from 1st April to 10th of April. The flow rates here are different for different day. If we draw the bar graph of flow rate versus the day on which the flow rate is available, then the bar graph is called as hydrograph, and it appears like the one shown here. In hydrograph, on y-axis, flow rate in meter cube per second is taken, and on y-axis, the day on which the flow rate is available is taken. Now here you can see a table in which the flow rates are arranged along with their days in descending order. Since the flow rates are available to us for 10 days, these 10 days we will take as 100% time. So 1 day of time will become 10% of the total time. 2 days will be 20% of total time. 5 days will be 50% of total time, and so on. So the flow rates may be now given with the percentage of time as shown in the next table here. Now if we draw the graph of flow rate versus the percentage of time for which the flow is available, then the graph is called flow duration curve. Such a curve for the table here is given now. So now we will define flow duration curve like this. A flow duration curve is a plot of discharge versus percentage of time for which the discharge is available. The flow or discharge can be expressed as cubic meter per second, per week, or other unit of time. If we know the head at which the flow is available, then the discharge can be calculated in terms of the kilowatts power P using equation P is equal to 0.736 by 75 Q into rho into H into neta, the efficiency symbol. Where Q is in meter cube per second, rho is the density of water. The density of water is 1000 kg per meter cube. Neta is the efficiency of plant. It varies from plant to plant, so its value will not be given. H is the available head in meters. So from this equation, we can understand that the power produced is directly proportional to H and Q. The efficiency for the given plant is constant. H is also constant and rho is also almost constant. Only the flow rate can change. So with available flow rate, we can calculate the power that can be generated, or knowing how much power is generated, we can calculate what is the flow rate. Therefore, the flow duration curve is also called as the load duration curve, is also called as load duration curve. Now we have to know what is the meaning of load in electrical engineering. I will give first a mechanical example. Let us consider here one truck. On this truck, if we put some mass, that mass will become load on the truck. Mass is load here. Similarly, in electrical engineering, if we consider one generator, denoted by G, to this generator I can connect load. I can connect load. Load means here the electrical appliances, the electrical machineries, or anything that works consuming electrical energy. Anything that works on electrical energy is called as electrical load. Electrical appliance is electrical load. Say for example, this generator is capable of generating a power of 100 megawatt, and if I connect here a load of 100 megawatt, then we say that generator is loaded to 100%. Generator is loaded to 100%. 100% loading we said. If this generator is connected to 50 megawatt power consuming appliance, then the loading will be 50%. And so on. So what is the meaning of load here now? Load means the power being consumed by a appliance, and how much power is consumed by any appliance, that much of power will be generated by generator along with the losses in the transmission line. So by this example we can understand that the load and power are interchangeably used in electrical engineering, since if we know the flow rate, we can calculate the power according to this equation. Flow duration curve is also called as load duration curve. Now we will take up classification of hydroelectric plants. The hydroelectric power plants are classified on the basis of location, and topographical features the presence or absence of storage the range of operating heads the hydraulic features of the plant the operation features etc. We will see first classification of hydroelectric power plants based on hydraulic features. First one, conventional hydroelectric plant. In these type of plants, the hydraulic energy of the flowing water of rivers is converted into electrical energy. Such type of plants may have dam or they may not have dam for storage of water. These plants utilize the normal available hydraulic energy of the flowing water of rivers. Dams may or may not be constructed. In this classification, second type of hydroelectric power plant is pumped storage plant. These type of power plants are used for meeting the peak demand. Such plants utilize the concept of recycling the same water by pumping the water back during off-peak hours. To understand the concept of peak load hours and off-peak load hours, let us see the efficiency versus percentage loading graph. Here you can see, as the percentage loading goes on increasing, the efficiency of any electric machine goes on increasing. After certain percentage of loading, the efficiency starts to decrease. There is certain percentage of loading for which the efficiency is maximum. All electrical machines are designed to operate at certain percentage of loading for which efficiency is maximum. But you can see below that percentage loading efficiency is less, and above that percentage loading efficiency is less. To understand what is peak load hour and off peak load hour, let us consider the diagram given here. There are two generators now, G1 and G2. One generator is of 100 megawatt. For other generator, I have not mentioned any power rating. The sum of all the loads here is 160 megawatt. For any combination of the load here which is equal to 100 megawatt or less than 100 megawatt, only the 100 megawatt generator will be sufficient to supply the power. So, up to 100 megawatt generator G1 can supply power to the load, and this generator is called as base load plant now. Base load plant. When it operates very close to 100 megawatt or at 100 megawatt, it will be having better efficiency. But when the total load on the system becomes more than 100 megawatt, say 160 megawatt, when the total load on the system becomes 160 megawatt, this generator alone cannot supply the load. So at that time, we will make use of generator 2. Then what is the rating of generator 2? That can be now calculated as 160 minus 100 megawatt, that will become 60 megawatt. If 60 megawatt generator is not available, then we have to go for higher than that. Say that is of 75 megawatt. When peak load is there, load taken by this generator will be 60 megawatt. So this generator will also be operating at a load closer to its rating. So the efficiency of generator 2 will also be better. So now the second generator brought here, when the load has increased above certain fixed load called as base load, that generator is called as peak load plant generator or peak load plant. And the time duration for which there is a base load or lesser than base load, that duration is called off peak hours. And the time for which the total load is more than 100 megawatt in this case is called as peak load hours. Now look at this diagram. Here is a reservoir, here is water outlet, turbine and generator, conductors for supplying load, and here is another reservoir. See, this generator is peak load plant now. It operates for only small duration of time in a day. So when it operates, it will take water from this reservoir, generate power and give it to the consumers. During off peak load hours, this generator will be made to operate as an electric motor. Then this turbine will lift the water from this lower reservoir to the upper reservoir. So again, during next peak load hours, this generator will generate power. That means the same water is used many times here. This is called as water recycling. And such type of power plant is called as peak load power plant. So now we will write what is pumped storage plant. Pumped storage power plants are used for meeting the peak demand. Such plants utilize the concept of recycling the same water by pumping the water back during off-peak hours.